What's something people don't know about black holes? Most people have heard of these mysterious objects, but the truth is, black holes are far stranger and more fascinating than science fiction could ever imagine. They're not just the monsters of the cosmos, lurking in the darkness, waiting to swallow up everything in their path. In fact, black holes are among the most important and influential objects in the universe, shaping galaxies, bending the very fabric of space and time, and challenging our understanding of physics at every turn. They're not just cosmic vacuum cleaners. These mysterious objects might actually shape the universe itself. Imagine a force so powerful that it can sculpt the structure of entire galaxies, influence the birth of stars, and even play a role in the evolution of the universe from its earliest moments. Black holes are not just passive consumers, they are dynamic engines that can trigger the formation of new stars, regulate the growth of galaxies, and send out powerful jets of energy that can be seen across billions of light years. Let's dive in. Black holes are like space's ultimate trapdoors. Picture a region in space where gravity is so intense that nothing, not even light, can escape its pull. If you were to fall into a black hole, you'd cross a point of no return, known as the event horizon, and be lost to the universe forever. But what exactly happens inside a black hole? That's one of the greatest mysteries in all of science. The laws of physics as we know them break down, and time and space become warped in ways that are almost impossible to imagine. They're born when a massive star, at least 20 times heavier than our sun, runs out of fuel and collapses in on itself, unleashing a titanic explosion called a supernova. The outer layers of the star are blasted into space while the core collapses under its own gravity, shrinking smaller and smaller until it forms a black hole. This process is one of the most violent events in the universe, releasing more energy in a few seconds than our sun will emit in its entire lifetime. The result is a gravity well so deep that nothing, not even light, can get out. This is why black holes are invisible. They don't emit any light of their own, but their presence can be detected by the way they warp the space around them, bending light from nearby stars and distorting the view of the universe like a cosmic funhouse mirror. Sometimes, matter spirals into a black hole, forming a glowing disk of superheated gas called an accretion disk. As this material falls in, it heats up and emits powerful X-rays and other forms of radiation, lighting up the darkness and revealing the black hole's location. At their center lies the singularity, a point where all the star's mass gets squeezed into infinite density. The singularity is a place where the known laws of physics break down completely. Here, gravity becomes infinitely strong, and space and time as we understand them cease to exist. No one knows what really happens at the singularity because our current theories of physics simply can't describe it. Some scientists believe that understanding the singularity could unlock the secrets of quantum gravity, the holy grail of modern physics. Surrounding it is the event horizon. Think of it as a one-way border. Cross it, and you're gone for good. The event horizon marks the boundary beyond which nothing can escape the black hole's gravity. If you were to watch someone fall into a black hole, you'd see them slow down and fade away as they approach the event horizon, never quite crossing it from your perspective. But for the person falling in, time would seem to speed up, and they'd be pulled inexorably toward the singularity at the center. But not all black holes are the same. In fact, black holes come in a wide range of sizes and types, each with its own unique properties and mysteries. Some are tiny, with the mass of a single star, while others are truly colossal, containing the mass of millions or even billions of stars. Scientists have even theorized the existence of microscopic black holes, which could have formed in the earliest moments of the universe. Some are just a few times the mass of the sun. These are stellar mass black holes. They form from the collapse of massive stars and are often found in binary systems, where they orbit a companion star. As matter from the companion star is pulled toward the black hole, it forms an accretion disk and emits powerful X-rays, which can be detected by telescopes on Earth and in space. These stellar mass black holes are scattered throughout our galaxy, and astronomers estimate that there could be millions of them in the Milky Way alone. Others, called supermassive black holes, sit in the heart of galaxies and weigh millions or even billions of suns. These cosmic giants are found at the center of nearly every large galaxy, including our own Milky Way. The supermassive black hole at the center of the Milky Way, known as Sagittarius A*, has a mass of about 4 million suns. No one knows exactly how these behemoths form, but they play a crucial role in the evolution of galaxies, regulating the flow of gas and stars and shaping the structure of the universe on the largest scales. There might even be tiny ones left over from the Big Bang. These so-called primordial black holes could have formed in the chaotic moments after the universe began, when density fluctuations in the hot, dense soup of particles created pockets of extreme gravity. If they exist, primordial black holes could help explain some of the universe's biggest mysteries, such as the nature of dark matter and the origin of supermassive black holes. So if they trap light, how do we find them? Black holes are invisible to ordinary telescopes, but astronomers have developed ingenious ways to detect their presence. One method is to look for the effects of their gravity on nearby stars and gas. If a star appears to be orbiting an invisible companion, or if gas is being pulled into a region of space with no visible object, it could be a sign that a black hole is lurking there. Another method is to search for the powerful X-rays and radio waves emitted by matter as it falls into a black hole, heating up to millions of degrees in the process. We watch for stars dancing weirdly around invisible partners, or spot X-rays blazing as matter spirals in. Some black holes also produce powerful jets of particles that shoot out at nearly the speed of light, creating spectacular displays that can be seen across the universe. These jets are thought to be powered by the intense magnetic fields and spinning disks of matter around the black hole, and they can stretch for thousands of light years, lighting up the darkness and revealing the hidden power of these cosmic monsters. Black holes may be invisible, but their effects light up the cosmos. They can trigger the formation of new stars by compressing clouds of gas, regulate the growth of galaxies by blowing out powerful winds, and even shape the large-scale structure of the universe itself. In recent years, astronomers have even detected the ripples in space-time caused by the collision of black holes, gravitational waves, using incredibly sensitive instruments like LIGO and Virgo. These discoveries are opening up a whole new way of exploring the universe, allowing us to hear the cosmic symphony of black holes merging and colliding in the darkness. And who knows, maybe they hold the secret to the universe's biggest mysteries. Black holes challenge our understanding of space, time, and the very nature of reality. They force us to confront questions about what happens at the edge of physics, where gravity and quantum mechanics collide. Could black holes be gateways to other universes or even time machines? Could they help us unlock the secrets of dark matter, dark energy, or the origin of the universe itself? As we continue to study these cosmic monsters, one thing is certain. Black holes are not just the stuff of science fiction. They are real, they are powerful, and they are key to understanding the universe we call home.